Solving quadratic functions by graphing. In this table, we see the graphical representation of three quadratic functions. The solutions to those functions are the places where the graph crosses the x-axis. This first function has two real solutions. The solutions are 6 and 2. This quadratic function has one real solution, namely x equals 2. And this quadratic function has no real solutions. There is no place where this curve crosses the x-axis. So here we have a quadratic equation in one variable, but if we consider it like a quadratic function written in standard form, and we graph this quadratic function, we can solve the equation by finding out where the curve crosses the x-axis. So we usually start by finding the axis of symmetry by substituting in our a value of 1 and our b of 0. So x equals 0, or the y-axis, will be my axis of symmetry. The y value of the vertex can be found by substituting 0 in place of x in my function. So on my coordinate plane, 0, negative 36 will be my vertex. This quadratic function will open up. So let's find f of 5. Just by substituting 5 in place of x in the function, we know 5, negative 11 and negative 5, negative 11 will both lie on this curve. Now by inspection, it may be obvious to you that 6 and negative 6 will be the roots. Those are the values that I substitute in place of x that get 0 as a y value. So when I connect these points with a smooth curve, we can see there will be two solutions for the quadratic equation. It's the places where the graph crosses the x-axis, negative 6 and 6. All right, so here's a quadratic equation, which if I write it as a function in standard form, we can find, once again, the axis of symmetry. Again, will be the y-axis. The y value of my vertex is negative 2, so I can plot 0, negative 2. That's my vertex. Now this function will open down, you'll notice, because the quadratic term is negative. So let's find f of 1 and f of negative 1. Now this gets tricky because you want to pay attention to that negative in front of the x squared term. That means the opposite of x squared minus 2. So we can plot 1, negative 3 and negative 1, negative 3. And now let's find f of 3 and f of negative 3. We'll plot those 2 points and we'll connect our points with a curve. We'll notice this graph does not cross the x-axis at all, therefore the quadratic equation has no real solutions. There's no real number solution for x which would make that equation true. Okay, once again, we'll write this as a quadratic function in standard form, keeping the x squared and the constant on the left. Let's bring that linear term over to the left side. We'll find our axis of symmetry, which will be x equals 4. We'll use f of 4 to find the y value for the vertex. We'll plot 4, 0. This is the vertex. So already I know if this is the vertex, then x equals 4 is also the solution to that quadratic equation. But we'll carry it out by graphing the quadratic function. We'll connect these points with a smooth curve, and we can see that that one place where the curve crosses the x-axis, x equals 4, that is the solution to the equation. It has one real solution. Okay, so very often you'll have a calculator portion of a test, and you'll want to know how to use your graphing calculator. So the first thing is, we've already gotten practice writing the function in standard form, and that's a really good first step with a graphing calculator. Now, if you don't have a calculator handy, you can also use Desmos.com. It's a free app, which is a really nice interactive graphing calculator. You can type it in, the function in exactly the way you see it, and you'll get this curve. We can see that we do have one place that the curve crosses the x-axis, and so there is one solution, x equals -3. We'll have another example with the graphing calculator. This time let's pull the quadratic term on the other side and the constant term on the other side. And let's type it in exactly like that into Desmos. And we'll notice this particular graph does not cross the x-axis, so the quadratic equation has no real solutions. So using these examples that we've given you in this tutorial, we'd like you to try these sample problems, solving quadratic equations by graphing related functions, both by hand using graph paper and on a graphing calculator.